So it's my pleasure to welcome Andrew McPherson, who is currently working toward his PhD at UC Berkeley in mechanical engineering in the Embodied Dexterity Group. He is also the board chair and co-founder of Ability Hacks, a nonprofit bringing together community members with disabilities and volunteers to teach and build solutions to disability-related challenges. Drew's passion for creating assistive technology stems from his own experience of becoming paralyzed in 2006. He was also a co-founder, president, and instructor of Enable Tech at UC Berkeley. So take it away, Drew.
All right, hold on 1 second. Gotta find a tab. All right, thank you, Laura, for the intro, and thanks for coming to the workshop. As she said, working on my PhD in the Edge Lab. And my goal today is to kind of talk about my experience as a researcher, engineer, and user, hoping to motivate even more helpful assistive devices to be kind of designed for users like myself. Since becoming paralyzed in 2006, I've been kind of problem solving and designing my own devices and conducting informal and formal interviews in a variety of settings, and just trying to kind of distill some of the findings I've found from that. Just for context, also I have a C5-6 spinal cord injury, so I have some wrist movement, but no finger motion. So first I want to go over some of my experience organizing community projects and some of the lessons I've learned. So like you said, at Cal, I co-founded Enable Tech, a student organization bringing together community members with disabilities and engineering students to develop custom assistive tech solutions. This kind of came out of seeing students really wanting to work on meaningful projects and talking to friends and community members about kind of challenges they faced. It lots of people would come up to me and be like, hey, this is, I can't do this, or hey, I have this idea, like how can we build it? So we wanted to kind of bridge those two communities and see, develop solutions through that kind of ecosystem. After graduating, I continued this by co-founding Ability Hacks, and that was in an effort to bring community members with disabilities even more into the machine shop, the makerspace, so they could kind of be empowered to design and build their own solutions. One of the fantastic things about digital fabrication is, allowing some distance from the designer or fabricator so that folks with limited function can design and build their own devices. Some of the more successful projects was the off-road wheelchair, a key guard, and then the voice activated hospital bed is just kind of a Wi-Fi dongle that controls a variety of makes of hospital beds. So you can use your, Alexa or Google Home to control that. And that's been fun to see folks across the United States kind of rebuild it, because we've made it open source and, kind of crowdsourcing that development. So some of the, thoughts and takeaways I've had from this experience is, initially I was very hyper-focused on prototypes, and the prototype being like as functional as it could be out the door and really being product ready. And then often being disappointed myself as a kind of a mentor, as well as, seeing frustration in the students and the community members if it didn't, get executed perfectly the first time. And through kind of many iterations of that and conversations, I came to the realization that, the product that we're really developing is education as opposed to the, prototype. And I think that really helped me reframe and anticipate some of the challenges and kind of manage expectations both of the students and the community members. One factor that we did find that really kind of had a bearing on how successful projects were is, how engaged both the community member or the kind of end user was with the students, because as the students kind of built friendships with the user, as well as saw the impact that they could potentially have, they're, became much more engaged and committed to making something that was super useful. And that even kind of extended to, seeing students after they graduated several years later, still staying in contact and, troubleshooting if wires broke or if something happened, that they could help kind of fix that. And that was also one of the impetuses for those organizations, is to have ongoing support for these types of prototypes that, inevitably break eventually. I think a really strong element of this educational ecosystem or environment is just kind of the creativity that comes out of it. There's designers and non-designers, students kind of excited about what kinds of solutions they could come up with. And then a lot of this community need finding where, people often know what they need, but there's not a lot of crosstalk with engineers, with students, in terms of what could be useful. Lots of times they could be pretty simple solutions. So, bridging that and having that environment. And, the two kind of primary stakeholders that I see is the students and the community members. And I think we can, like, if done correctly, both really benefit from the experience. The students learn kind of empathetic design, they learn about somebody else's lived experience, and they get real feedback from kind of an end user, while the community members are able to, certain individuals like working with students, and those individuals have talked about how they enjoy kind of the mentorship, the outreach, the kind of disability activism, that they're able to share their experience and kind of influence new young engineers to consider what, how people would use devices, as well as, often they've talked about looking critically at their life and some of the challenges they experience in a different way after making kind of one solution, or seeing how they could come up with something that would be easy or make life easier. They often start thinking about other areas of life that would be helpful. And then obviously, useful prototypes are always what we're aiming for. So now I'm going to talk a little bit more about my personal experience as a user and the assistive technology I use, and kind of some of the design considerations and categories I think can be constructive. So from my experience, there's a significant discrepancy between the technologies I think I should use and what's actually available. I mean, in the exoskeleton space, who wouldn't want to have, an Iron Man suit and fly around? But what I actually use on a daily basis, as Laura alluded to at the beginning, is, very old, kind of simple passive technologies. And that's what's, provided through therapy, through insurance. That's also just really what exists directly on the market. And since becoming paralyzed 16 years ago, I've paid a lot of attention to, tools that could make my life easier. And I haven't seen a lot of change in that. There's been a lot of technological and great kind of research advancements. But any of this could have been designed, if not, it was designed 15, 30, even 60 years ago. And there's a lot of factors to that. We could do a whole talk or workshop on why there's, this breakdown between research, between, developments, and why it's not making it to folks in the home. But we'll save that for another day. I do think it's helpful to think about while, looking at the devices I use, is looking at kind of task-specific tools versus universal tools. And kind of examples I see are, like a kitchen knife, like a spoon. This is a hand cycle glove. Those are very specific to, one thing, and they work great for that. But they don't work great for other things. Whereas, this wrist-driven orthosis, my wheelchair, those are really replacing functions that I've lost due to my injury, and allow some versatility of kind of function. So building off of that, I think there's an important trade-off to think about when we're looking at kind of task-specific tools versus universal tools. And when, say, like a spoon, it's a very task-specific tool, but it's going to have to be really easy to take on and off. As a user, I'm going to be pretty lazy and come up with alternative ways of doing things if I have to, spend 5 minutes putting the device on just to, perform a task for 1 minute and then have to take it off again. So that's not going to work. But if the device is fairly universal, and it can do kind of all sorts of different tasks, and it doesn't inhibit other tasks that I can do without the device, it's okay if it's much harder to take on and off. So I think like there can be a sweet spot, and I think as we're designing specifically hand exos, where that's really how we interact with the world, that these devices are actually like baked in from the beginning, going to be usable, and you can actually take it on and off. If there's a device I need a care attendant to put on, that's pretty much a non-starter, and I don't foresee ever using it unless it's of course a rehab device. Some of the kind of research devices I do see that are getting at this and doing it really well, the ExoGlove Poly, having that soft glove, and the thought that went into how to put it on, take it off, the fact that it really is pretty unobtrusive. It's not going to stop me from doing a lot of the tasks I would do without it on, and I can wash my hands with it on. I can do a lot of my daily tasks without having to take it on and off. So it's okay even if it takes a little bit of effort to put on and off. I think the Relab Tino Exo is another great kind of slim actuation device that's looking at different kind of user input, user control. I see that as certainly an area of research that needs a lot more focus. Simply having buttons is, a challenge to have it kind of seamlessly integrate into the tasks that I'm doing. And then the Vanderbilt hand, I think, is also a great kind of power grasp. It has limited function, but it's something that would be easy to take on and off and provide significant function. So the last thing I want to go over is just a simple thought experiment about the assistive device I use the most. And this is the first thing I put on in the morning, the last thing I take off at night. And these are just push palm gloves. So they just provide extra friction on my palm. Super simple. I can get them wet. I can wash my hands even with them on. I have one pair for dressing. I have one pair for cooking. I have one pair for when I leave the house, go to work. And they're just super useful for all kinds of things. And that's because they provide, grip so that I can do things like pull my pants up, pull my shirt down, grab something bimanually off a table. And they're not giving me prehensile grasping. They're not, recreating my hand function, but they're giving me just that kind of slight advantage to be able to do a lot more tasks that I, can't do without them. So I think that's a useful, thing to think about is, do we really need to reproduce the, pre-existing motion of the body? For an assistive device, certainly for a rehabilitation device, yes, that would be the goal. But for an assistive device, can we abstract away what would give useful function from, having to just reproduce the previous function? And I don't have much time, but thinking about evaluation, I'm excited to see that contextual inquiry and kind of the egocentric video evaluation is getting more attention, and especially in the spinal cord kind of device evaluation field, because there is a lot more that goes on to our choice to use a device and how we use a device in the home versus just simply testing it in a lab setting. So just to recap, the primary takeaway from my teaching and community experience is really that it's an educational process, and kind of the cherry on top is that prototype. Obviously, the prototype is the goal, coming from the beginning, or that's kind of the hope, but that's the overall kind of outcome, as well as task-specific versus universal tools, on and off ability versus versatility, and just looking at device evaluation. So with that, I'll open it up for questions. Thank you.
So much, Drew. Thank you so much, Drew. That was a wonderful talk. I have about 1 million questions, but I'll just ask one to give other people a chance as well. So I guess you gave us a great sense of sort of, you know, how the insights and takeaways that you've had from running these running ability hacks and these community programs, and also from being a user yourself. I'm curious, you know, now you are a graduate, you are a PhD student working towards, you know, this this area from an academic perspective. I'm curious how, you know, these experiences have colored the kinds of, you know, as scientists, you know, and as engineers, we're interested in problems for their own sake, kind of in this space, and how that's colored your, you know, what you're now studying as a graduate student and your plans for what to study going forward. Drew?
Yeah, I'm here. I'm thinking about that. Yeah, I think I guess I'm torn between the kind of dichotomy of abstracting away in a research setting, like looking at a very specific question, versus the need to really bake in usability of a device or a technology from the very beginning. And so that is definitely something that I'm working on or working with, and just more seamless kind of usability, how we can take the residual motion that I have, say, you know, my wrist, and use that as a control input for grasping like I already do, or, you know, we're working on a haptic device for prosthetics, and just like how do we increase embodiment of a device and make it more seamlessly kind of integrated into the motion that we'd already be using.
Cool. I'll open it up to audience questions. Anybody? All right. You'll have plenty of time to ask him questions during the panel. I think we're running a little bit behind, so I think we'll move on to our next presenter, which will be David Lin.